In this video, we will practice using MATLAB to identify terms in the Fibonacci sequence. Specifically, we will be looking for the 50th term, and we will be using a for loop to complete our analysis. As a reminder, the Fibonacci sequence is a special type of number sequence that starts with the numbers 0 and 1, and then all of the following numbers are found by adding the two numbers before them. So the third number is 0 plus 1 equals 1. Then we get 2 is 1 plus 1 equals 2. We get 1 plus 2, that gives us 3. We get 2 plus 3 is equal to 5, and so on and so forth. This starts to become difficult though if we want to add up 50 numbers by hand. Instead, we'll have the computer do it for us. So when we set up our analysis using MATLAB, the first thing we'll start out is by defining our input variables. So I've identified that we need to calculate 50 terms, so we'll specify that the number of terms that we want is equal to 50. The other two numbers that we need to know are that the first number is equal to 0, and the second number is equal to 1. Those are the numbers that we're going to need to complete the rest of our analysis. Everything after this is going to refer to those numbers. Now what we'll do is we'll set up an array that we're going to fill with all 50 numbers. So we'll keep track of all 50. So we're going to call this Fibonacci all. And we're just going to create it to be full of zeros. We need to put some sort of placeholder in it, so we'll put zeros. So we'll use the zeros function in MATLAB, where our first parameter is n terms. And then we wanted to be only long in one direction, so the second dimension is just going to be equal to 1. After creating this initial array, we'll start filling it in with numbers. So the first two numbers I've already given to you, so we'll start with those. So first we'll specify that the first number in this array, Fibonacci all of 1, this is equal to the variable Fibonacci first that we defined before. The second value, Fibonacci all of 2, we specified that this is Fibonacci first, this is Fibonacci second. I am going to add the semicolon here to prevent the output from being printed to our screen. It just makes it clearer and helps our code run faster. Now we need to start adding in the third, the fourth, and the fifth numbers to our sequence. So the way we would get our third number, we'll just write this out for now. This would just be equal to the first number plus Fibonacci all of 2. If I wanted to do this for the fourth number, you can see we would go from 3. We now need this to be the fourth number, and now I change the 1 to a 2 and the 2 to a 3. So this is going to be the second number and the third number. And I'm just doing this to show you how we're mentally solving the problem, because once we figure out and we see how we're going to solve the problem, we can use this as our framework for filling in the rest of the numbers. You can see that we're going to need to do this for numbers 3, 4, all the way up to 50. So that tells us that we're going to want to do a loop. I'm going to use a for loop. I'm going to loop over numbers from 3 to 50. Sorry, 3 to our final term. We've already filled in 1 and 2, so we're going to start with 3 and go up to the last one. It's really convenient to do it this way because we want to so that we don't have to, we know that we just want the third, the fourth, and the fifth, so we'll make our code as simple as possible. Rather than going from 1 to 48, I'd rather go from 3 to 50. I also here you can see I've used the variable I, or II in this case. I do that because these are going to be our counters, so we're going to need to refer to that, and I's and J's are really common ways when we start getting into our variables that we're going to be referring to parameters. So the second or the third or something in a sequence, we'll just be using i's and j's. And I'll go ahead and I'll end my loop. Now what we need to do is we need to tell our loop what it needs to do. So it's going to do something 48 times, but it doesn't know what it needs to do 48 times. So what it needs to do is it needs to take this equation I've already set up, and we just need to generalize it. So you can see the first number here, this is the number that we're trying to fill in. So we'll replace the 3 with II. And the numbers that we want, instead of 1, that's 1 is really 3 minus 2. So this is II minus 2. For the last one, instead of 2, that's really 3 minus 1. So II minus 1. This is going to then run for I equals 4, where it'll plug in 4, 4 minus 2 is 2, and 4 minus 1 is equal to 3. So this is going to do it for all of the numbers in our sequence. The last part that I'm going to add is at the end of this, I want to make sure I output my final answer. So I'll output this. My last one is going to be n terms. And this will output it to our command window. Now that we've finished setting up our simulation, what we can do, I'll add a comment here. Remember, comments are good programming practices. And this is going to fill in the 3rd through 50th terms of the sequence. So we make sure to save our M file, and then I'm going to click Run. This is going to run in our MATLAB window, so I'll go over and I'll open that window. I'll switch to that window. You can see this is the output of my file, my M file tutorial Fibonacci, 50 terms, starting with 0 and 1. The answer is going to be on the order of 7 billion. However, this is using a shorthand notation. It's not giving us all of the digits. So to have MATLAB do that, what we can change is we want to use the function format and specify long E. I'll show you what this does by typing an answer again. So this is going to output whatever our last variable was here. And you can see what this does is it changes the number format to show all of the decimals, all of the numbers that were calculated by the computer. And so if we were to look at these, we count these up, we see that there's 9 digits after the decimal point. So this number is 7,778,742,049. This gives us the 50th term in the Fibonacci sequence.